Hey guys, so I actually had some time tonight. I wanted to go ahead and move on to another video for the Snap data project here. What we're going to do, just really simply tonight, is there was one last, couple last steps in cleaning the data that I really should have included in that last video, but they can work on their own as just one topic. So, first things first. Let's go ahead and import NumPy and pandas as PD. I'm going to go over to a previous notebook and just read in what we had already done yesterday. I might skip ahead here because it's just going to be a lot of copying and pasting. Here we go. So all this should bring us right back up to where we were yesterday. Good. Okay. So here we are. We've got our data frame as it is, and the first thing that I wanted to mention I didn't get to yesterday, I forgot to, was whenever you're doing this, as you saw here, you can run this huge line of code, and that can be how you start up your program, or not program, your analysis, your notebook. But I find it's a little bit easier just to write a new file once we've cleaned everything up, so that way you don't make any changes to the original CSVs, and you don't have to read in all these lines of code first. So pandas has a file writer function. And it basically starts with 2 and underscore. And if you hit tab, you can see 2Excel would be an Excel spreadsheet. A lot of things that you can do here. But we just want to do it to a CSV. And I'm going to put this under, I think, yes, Snap Project Master CSV. Index equals none. If you don't put that in there, if you don't assign an index, the CSV will include these index numbers over here, and it'll add another row, and then whenever you read it again, you'll have this unnamed row. So I just get in the habit of doing the index equals none right now. There we go. And just to show you that it worked, let's see, we're going to do T5 equals PD read CSV and Snap Project Master T5. There we go. Okay, so that takes care of that. That's pretty simple and straightforward. The next thing that we're going to do is, I was actually noticing as I was sorting through some of the data after I made the video last night, I thought I need to have an easier column of state and county information. And luckily we have it all here in the geo display label, but it all starts with census tract 9501, Appling County, Georgia. Now, I don't need all of that. In fact, I just want one column of the county name, and I want another column of the state. So there's many ways to do this, but the way I'm going to focus on here is going to be what's called the split function. And basically it works like this. You bring up your data frame and the column that you are interested in, and then it's a .str for string, .split, and we're just going to run it with the open and closed parentheses right now. We're not going to pass any additional arguments to it because I just want to show you generally what it does. So it is looking for, looks like every place that there is a space, it is adding, it's separating them. Now right now it's just a series, so it isn't doing much of anything. But what we're going to tell it to do next will make everything a little bit easier to read, and then we're going to assign it to its own data frame. So first things first, you assign the delimiter. In this case, right now, the delimiter is the space. If you're not familiar with why a comma-separated value file is called that, it's because all of the data is delimited using a comma. And I want to do essentially the same thing, and I'll show you the easiest way to do that is just simply to put in quotation marks or apostrophes there, a comma. There we go. And we because you can tell by the brackets on each end, it's still coming up as kind of a list, and it's still not useful to us yet. So we want to do expand equals true. There we go. Let's save this as a new variable. Let's see here. I have to try something. I might have to jump cut. Data frame. Good, that worked. Okay, so now we have our county and our state names. Perfect. But now we need to move those over to the T5 element, because right now they just exist in their own data frame, and that's even easier to do. But before we do that, I want to rename these two columns, because I don't like having numbers in there. If you were to, well, for instance, T6, 1, it doesn't know what to do with that. A number is not a column name. So, go ahead and that. Let's do T6.rename columns, and this is going to be different than other renames we've done. We're still going to do the open curly bracket, but instead of putting the column name, in this case the number, in quotation marks, we're just going to tell it the number that we want. So it's 1, 2. Then colon, quotation marks, 1 is county underscore name, comma, and 2 is state underscore name. Just gonna enter it first, confirm that it worked. Then we go back into the code, hit comma, and then in place to save over our T6 variable. It's in place equals true. All right, so now we have those names, and simply just to put it into T5, you're going to do T5, open bracket, and tell it T5, I want a column called county name, and that will equal T6 county name. And I want T5 to have a column called state name, and you can probably see where I'm going with this. All right. Very good. Now I'm just going to reorganize these just so it's a little bit easier to check. Let's see, that's right. Let's do columns and T5 open brackets, and let me copy and paste this. By the way, if all of you watching see and know I can do this, or know an easier way to do this, please don't be shy in letting me know. I'm going to go and get rid of the GeoDisplay label from this because I really don't need it anymore. And let me save this as a new variable to T7 just to get in the habit again. There we go. Okay, so part of the reason why I wanted to do this is to lead into data analysis, and I'm going to get to that another time more in depth this weekend. But I wanted to do this video first to give another exercise on how to change the data frames around, how to basically make 2 new columns out of existing data. But one of the cool things about this, I'll get into more in depth here, but the reason why this makes it easier is if you wanted to say mean rent. You wanted to know what the maximum mean rent was. It's $3,500. But what if you wanted to know what state has the highest, or what is the highest rent in each state? So we'll do t7.group by state name. And there we have a complete list, but we're going to do it by sorting values, and ascending equals false. There we go. Georgia has the highest. North Dakota has the lowest at 1681. Well, the lowest, highest, I guess. And everything in between there. And of course, we could also, now this list is going to be huge, but and you can go one step further. There we go. So now we can see that Georgia has the 2 highest rents out of all the counties, followed by Kentucky at Jefferson County, Charleston, South Carolina. So you see, there's a lot more coming as we explore all this a little bit more. I just don't want to have you guys sit through another 30-minute video. So I will get into more of this later on, but for now, this is how you can use Python to, as of now, we've downloaded data, we've organized it, we've changed data types, we've now made 2 new columns out of information in a single column, and we are about to go on to analyzing data, eventually on to charts, bar charts, line charts, what have you. And then finally, I'm going to map all of this out, and that'll be the weirdest and most buggy thing, because not all values, or not all census tracts have values for all of this data, so it's going to look a little bit weird, but I chose everything at random. Yeah, it happens. Anyway, thanks a lot, guys. Again, I'll have a link to this Jupyter Notebook at my GitHub. And just go ahead and feel free to, I don't know, comment, I guess. I'm tired. Thanks. Bye.